Pre-calculus, Chapter 4, Lesson 5, and I wanted to do 3 examples of graphing these reciprocal functions and give you a little tip on how you might be able to do these quickly and easily by using the knowledge that we have about reciprocals, or the fact that these are reciprocals of the sine and the cosine. We know that the cosecant is the reciprocal of the sine, so wherever the sine has a value of 0, we're going to have our asymptotes. And the secant is the reciprocal of the cosine, so wherever the cosine has a value of 0, that's where those asymptotes will occur. So what we're going to do is to actually graph the sine or the cosine first, and then once we have that on the graph, we can easily see where the asymptotes occur, and then we can easily sketch these functions. So let's begin by doing number 1 here, and hopefully you'll get an idea of what I'm talking about. The cosecant is the reciprocal of the sine. So rather than graphing or jumping right to graphing the cosecant, I'm going to imagine that this is actually the sine. So I'm going to use the sine, keeping the same horizontal stretches or shrinks, and keeping all that the same, but just changing this, okay? And you'll see why in a few moments. This is a vertical stretch of 3, so the sine function, rather than reaching a maximum of 1, is going to reach a maximum of 3. So that's the only transformation of this. So we're going to graph this sine function, and we know that the period of the sine function is 2, so this will be the period. We're going to divide that then into its 4 parts, and then use the pattern. The sine starts at 0, it reaches its max, which is now at 3 because of the vertical stretch, back to 0, its minimum, its maximum, 0, excuse me, then back to its maximum and minimum. So if I was to sketch this sine function, it would look something like this. And I usually put this on here very lightly in a dotted line just so I can see it. Now that I have this sketched, I know where the asymptotes occur for the cosecant because it occurs wherever this is 0. So there's going to be an asymptote here where the sine value is 0, here where the sine value is 0, here, and here. And then I know that when the sine value is increasing, the secant is decreasing, and it is the same value, and then reaches back up here, and then over here. It climbs while it's falling, and falling while it's climbing. I don't know if that makes sense, but you get the idea. All right, and so what I have now is the cosecant function here graphed, and I use the sine function in order to do that, so that can help me quickly ascertain where these asymptotes occur. Okay, and so I would just sketch this very lightly or with a dotted line, and then solid lines when I graph the actual cosecant function. Okay, so I hope you see how graphing the reciprocal function first makes it easy to graph this function because it easily locates the asymptotes for me. All right, let's take a look at number 2 here. This is the now this is the cosine, or the reciprocal of the cosine. So this is, I'm going to rewrite this as cosine, and then this is 1/3 theta. That's kind of a crummy looking 3. Let me redo that. Cosine, and then 1/3 theta. So we have a vertical stretch of 2, so this is going to reach a height of 2 rather than the normal 1. This is a horizontal stretch of 3, and you remember we can determine the period by doing 2 pi divided by this value of b, and then I multiply by 3, and so I get a period of 6 pi. So this period is 6 pi. So then to get my 4 key points, I divide that in half, that's 3, and then divide that in half, that's 1.5, so that'd be about right here, and then this 1.5 here, and then 1.5 here, and then 1.5 here. So I have my values, and then I'll do my pattern. So the cosine starts at its max, 0, down to its minimum, 0, back to its maximum, 0, minimum. So again, if I quickly sketch the cosine wave in here, so it looks something like this. And then now I can see where my asymptotes occur at any 0 value of this function. So there's a 0 value here, a 0 value here, and then a 0 value here. And so then I have my asymptotes, And now I can sketch the secant, because as this cosine begins to fall, the secant is rising. And then I just draw these little U shapes in between the asymptotes. And it looks something like this. And then so here we have the graph of this cosecant function. Okay, again, using its reciprocal to help me out. So for this example, this is the reciprocal of the sine. So I'm going to graph the sine function first using these shifts and stretches, and then we'll use that to graph the cosecant. So this is a vertical shrink of a half. So rather than reaching a high point of 1, it's only going to go up to a half. And there is no shift or stretch horizontally, so the period is going to be 2 pi. And so if I was to divide these into its 4 pieces, my values would fall on these values here. However, everything is shifted pi over 3 units to the left. So I've got to kind of guess on this because my scale doesn't really help me out as far as something falling on a grid line. So if each of these, if 2 of these is pi over 2, then one grid line is pi over 4. So that's a fourth, and this is a half, and a third is somewhere in between. A little bit more than a fourth, but a little bit less than a half. So each of these is going to be shifted over a little bit more than a grid line. So this pi over 2 here, if I shift that over, is going to be a pi over 3 shift. It's going to be about right here. And then each one of these then is going to be 2 grid lines apart, because that's those values. So if I'm here, this is about a third, so I'll go a little more than 2. There's my next one here, and then my next one here, and then here, and then here, and then about here, and then about here. All right, so my 2 pi would be 4 of these, 1, 2, 3, 4. So this is 2 pi shifted. So here's my 2 pi shifted pi over 3 units to the left. Okay, so the sine function, let's see, this one's shifted over here, so this would be the 0. So sine function starts at 0, and then at the first one it reaches a maximum now of a half because it's been shrunk down. Then it's back to 0, then it's down to a half, then it's back to 0, then it's up to a half, then it's down to 0, and then it's down to its minimum half here. So this is a very shrunk down sine wave. So it looks something like this. So now that I have the sine function graphed, I know where my asymptotes occur. They occur at the zeros. So I've got a 0 value over here. I've got a 0 value right here. I've got another 0 value right here. Actually, that should be about right there. I didn't draw that one very well. And then another 0 value here. So now that I have my 0 values, I know that this is, I can draw my cosecant function. So it's going to reach this and like this. And then this one's going to come up all the way up here. And then this one's going to be here. And then this one looks like something like this. Okay? So again, it's pretty simple. If you draw the reciprocal function first, then the asymptotes are easily determined. And then also you can draw the cosecant function or secant function quite easily using this method.